Welcome again, ladies and gents, to another flipped lesson. Today our focus is going to be on assigning something called an oxidation number. These oxidation numbers are something we'll use this entire chapter, so this is a very important skill that we're going to get a lot of practice with the rest of the week. These oxidation numbers help us in identifying a specific type of chemical reaction called an oxidation-reduction reaction. So this video is going to be broken into two parts. Part 1, we're going to identify simple oxidation-reduction reactions. In Part 2, we're going to learn how to assign these oxidation numbers. So let's get started. We've looked at these oxidation-reduction reactions a ton this year. We just haven't defined them as oxidation-reduction reactions to this point. So an example of this type of reaction is going to be anytime you have a metal reacting with a nonmetal. That's always going to give you a redox reaction. So if we look at an example we're very familiar with, the reaction between sodium and chlorine, we know sodium is Na and chlorine is Cl2 because it's Hankel-Briff. And when they react, they make our friend sodium chloride. So if we balance this guy out, we put a couple of 2's there and we're done. So how do we know it's a redox reaction? Anytime you have electrons being transferred between atoms, it's always going to be oxidation reduction. And so that is the defining moment of an oxidation reduction reaction, when you have electrons being transferred between the atoms. We call these things redox reactions for short, which is what I'm going to refer to them as the rest of the video. So a redox reaction always includes electrons being transferred between atoms. Now, how do we see electrons being transferred? It's all about the formation of ions. If we think back to chapter 4, we know sodium is in column 1, so our two sodiums are each going to have one valence electron to start. We know chlorine is in column 7, so our chlorines are each going to have 7 valence electrons to start. And because chlorine is a non-metal atom, it's going to make a covalent bond to make itself octet happy. Now, when we put the sodium and the chlorine together, our sodium is going to want to lose those electrons to the chlorine to become octet happy. So our metal wants to lose the electrons, where our nonmetal wants to gain the electrons. So anytime you have one atom losing and one atom gaining, that means you've got electrons being transferred, which is going to give us our redox reaction. So that means our sodium is going to go from a neutral atom to a +1 ion because it lost an electron. And our chlorines are going to go from stuck to each other to -1 ions. And that positive and negative are going to attract, and that's what makes our sodium chloride. And so we know this is redox because the metal lost and the nonmetal gained. So that shows us that electrons are being transferred. So anytime you have electrons being transferred, it means it's redox, which is going to be every time you have a metal and a nonmetal reacting. Now, because of that, we need to identify what atom was oxidized and what atom is reduced, because those two things always happen in a redox reaction. So these are two super important definitions that you want to know. Oxidation is always going to mean you lose electrons. Reduction means you're going to gain electrons. So oxidation means loss of electrons. Reduction means gain of electrons. And how you can remember that is through a little saying called Leo the lion goes grr. So here's Leo over here, and he's in the process of grrring. So Leo stands for lose electron, means you're oxidized. Grr stands for gain electron, means you're reduced. So Leo the lion goes grr helps us understand what's being oxidized and what's being reduced. Lose electron means you're oxidized. Gain electron means you're reduced. And this always occurs on the reactant side. So oxidation and reduction always occur on the reactant side. So if we think from the last slide, we want to be able to identify what was oxidized and what was reduced. So we had 2Na reacting with Cl2 going to 2NaCl. We saw that our metal lost electrons and our nonmetal gained electrons. So because our sodium lost electrons, that meant he had to be oxidized. And because our nonmetal gained electrons, that meant that he had to be reduced. So in the process of making sodium chloride, we oxidize our sodium and we reduce our chlorine. So our metal was oxidized because he lost, our nonmetal was reduced because he gained. So I'd like you and your partner to go ahead and on this slide, practice identifying what's oxidized and what's reduced. So go ahead and hit pause, and once you've got them identified, come on back. Now that you're back to the video, I'm hoping you guys looked at your periodic table because it's all about identifying what's the metal and what's the nonmetal. Because we know that metals will always lose electrons, so that means your metals will always be oxidized. We know our nonmetals always gain electrons, so that means our nonmetals are always going to be reduced. So when you have a metal and a nonmetal reacting, your metals will always be oxidized, your nonmetals will always be reduced. So since Mg is in the second column on the left side, that makes it our metal. So that means our Mg is going to be what's oxidized in the reaction. Because O2 is on the right side of our periodic table, that makes it our nonmetal, which means it's going to be reduced in the redox reaction. If we look at this guy down here, aluminum again is our metal. It's going to lose electrons. So the aluminum would be oxidized. I2 is our nonmetal. He's going to want to gain electrons. So our I2 would be reduced. So when we have simple synthesis reactions between metals and nonmetals, it's very easy to identify what's oxidized and what's reduced based on the type of element you are. Because your metals will always lose, your nonmetals will always gain, so your metals will always be oxidized, your nonmetals will always be reduced. But what if I gave you guys a reaction like this? CH4 plus O2 gives us CO2 and H2O. One, it's not synthesis. Two, there's no metals present. But I know the carbon is oxidized, and I know the oxygen is reduced, because I've been doing this for a long time. But you guys don't know how that happens. This is where the second part of the video is going to help us. It's not always going to be as simple as looking at a metal and a nonmetal. These things can get really, 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 really tricky. So for that, we use those things called oxidation numbers, and that's going to be the focus of video number 2. So go ahead, finish off your notes, and I'll see you guys back here for video number 2.